Okay, thank you. Good afternoon, everyone. Welcome to my second live session in this 8-week course on data analysis for biologists. Possibly you have attended our last live session. In this live session, what I will do, I will go through certain logistical issue of the course, like how you should prepare. If you have registered for the exam, how you should prepare for the exam. At the same time, I will keep on discussing about, we are already in the 7th week, just 1 week is left. In my last live session, what I have done, I have discussed about the key points in week 1, week 2, week 3 contents, right? Week 4 is mostly data visualization. There is nothing much to discuss here. It is more upon you to practice those R script, how to visualize data. But week 5, week 6, week 7, what I'll do for these 3 weeks, I'll go through the points, key points that you should pay attention to when you are going through these lectures. You have already gone through week 5, week 6 lecture. Week 7's lecture is live right now, right? So you must have gone through some of those videos of week 7 and preparing for the assignment. But as I know, many of you have already registered for the final exam. So obviously before the exam, you will be again going through all these lectures and slides. So I will highlight the points, certain points. Please pay attention to those points while you are revising the course, right? This is, you can join us in this live session through the Teams, as well as you can join through the YouTube channel, right? And in both cases, you can post your question in the YouTube, in the chat box, you can write your question. If you are joining here in Teams, you can raise your hand or write in the chat box, right? So we can know what the question you are asking, right? Both cases, you can use the chat option here, fine. So now let me start with certain thing that we actually repeat every time. See, this is a live session by me, the course instructor. This is the last live session from my side in this course, in this session. But there is another live session that is happening every Saturday. Every Saturday, our PMRFTA for this course in this session, Arpit from ISC, is taking a 2-hour online problem solving session. This is a live session for solving problems as well as clear doubts, right? So in this session, what he is doing, he is going through the key points of that week's lecture content. Then we have a set of additional questions that I have provided him. He is demonstrating how to solve those problems. So for you, it is very important to join that. Many of you have joined it every week on Saturday at 6 p.m. This is a 2-hour live session. So many of you have joined, but many of you may have possibly missed it. If you have missed it, you can go back and check the YouTube recordings. All the links are provided in the course portal and the announcement section, right? So every week course content, there is a tab where these live session for problem solving and clearing doubt sessions are recorded and kept there. You can watch them. This week also on Saturday, there will be a live session discussing on the 7th week content, and Arpit will again solve some additional problem that I have provided to him. So please join it. See how he is solving the problem. You also try to solve them. Get the opinion from him, suggestions from him, take the help from him. At the same time, if you have doubt on any top issue of week 7's content or any other content, ask him. So it is very important for you to join. The Teams link is provided in the announcement section and the course portal. Please join it. This week, there will be one session, as well as the next week. Again, the TA will take another live session. And possibly before the final exam, an additional session, live session will be conducted. It is not decided when and all these things. So it will be, Arpit will communicate to everybody. If you have registered for the final exam, you must join that. So please join this live session or conducted by the PMRFTA to solve, which deals primarily on problem solving and clearing the doubts. Fine. Okay. So another important point that is important here, particularly for people who have registered for the final exam. This year, I see a good number of students have actually registered for the final exam. So you may have many questions. If you are, the student who has appeared in many other NPTEL exam, you may know the system. But otherwise, if you are new, then let me tell you that it will be a computerized exam, just like your GATE, JEE, other, right? And all questions will be MCQ and short answer type with a numerical value you have to write. This is the same format that we are using in our assignment, right? Okay. Now the question is, how should you prepare? You must have already noticed while doing this assignment for every week, you must have noticed one thing, that we are asking questions solely based upon what we have provided in the video, in the slide, and in the our script that we have used. We do not ask question outside the preview of this. You can have very interesting, thought-provoking, as well as tricky question, even from this content of video, slides, and the art script. So the final exam will have the syllabus of all topic taught in this course. And for that, you don't need to go back and read some additional book or something. You follow the lecture videos, slides of the lecture, and the R code religiously, thoroughly. If you do that, you will be ready for the final exam. And I can guarantee you will sail through very easily in this. But you have to go through them religiously, go through minutely, right? And at the same time, you have to practice. Practice what? Practice the solved problem given at the end of certain lectures. Look into the problem again given in assignment. Some of them you may have solved correctly. Some of them may be wrong. You have done wrong. You have done a mistake. Already the solutions are provided. To look into that solution, revise it, practice it using a paper and pen. And also look into the additional problem that I have given to Arpit to solve in the live problem solving session on this every weekly Saturday one, right? So go through those questions yourself. Try to solve yourself by paper and pen. Please do this. This is a mathematics oriented course. So you just reading something will not help you. You have to solve the problem yourself using a paper and pen. Do that. One important question. If you are giving the exam, you may wonder whether there will be question based upon R or not. Yes, there will be question based upon R. Even in the assignment, you must have seen there are question based upon R. R is the programming language that we are using in this course. You have to know how to use it. You have to be confident enough on those topics that we have shown in these videos, like R for linear regression, R for multiple linear regression, all these things, R for making a scatter plot. So there will be a question based upon R where I may give you a particular script and ask you what will be the output of it. So you have to understand what the script is doing. Or we may ask what is the function role of a particular function, or what is the role of a particular argument in a function. These are all based upon only the R topics that I have taught in the course, not from something else. You don't have to get a book on R and study it. No, follow the script that I have provided. Follow the R script, those R script, follow the lectures, you will be prepared. Fine. So all R codes are available in our course portal, just below the lecture videos. If you want to download from as a whole, all of them together, you can go to my GitHub page. The link is given here. You can download it. Fine. You can download all at a go and then you can use it. But please download them, play with those R script, edit them, change them. There will be mistake. Code will not work, but that is the way you will learn it. Fine. So the next one important point, again, I'll remind you, whether you are joined by Teams or YouTube, it doesn't matter. If you have any question during this live session, please post that immediately on the chat box so that I can answer the question. Fine. Any question about the course content, exam issue, anything if you have in your mind. Fine. Okay, now comes about another important question that people ask, particularly who will be appearing for the final exam. As I said, this time large number of people have registered for it. about the calculator. Just like any other NPTEL exam, you will not be allowed to take the your own calculator in the exam hall. The software for the exam itself provides a scientific calculator. I have given a similar calculator's link here. You can check it if you have never used it. You can check it. Otherwise, if you have given GATE or JEE, you must be quite habituated with this calculator. You will not have access to any online tool other than that, right? All problems will be such that you can do by paper and pen or by using this scientific calculator provided along with the software or the interface of the exam software. So now I'll stop for a minute, and then what I will do, I'll start from week 5 and highlight the key points. Those are essential for you to learn very well and prepare for exam. Okay, so I do not see any questions here. So then let me move on. Week 5. The first thing that we learn in week 5 is correlation. Actually, any data analysis, if you are an experimental biologist or a data analyst helping for a company or a research group to analyze data, usually the first question that you ask, I have so many variables, 5, 6, 4 different variables. Is there any association between these variables or correlation between these variables? To know that, actually, we have 3 very well known. There are many. We have discussed 3, which are very common. The most common one is the Pearson one. Then there are Spearman and Kendall one. Each of them has a unique definition. We know the value range possible for each of them. Each of them has a limitation and utility. For example, Spearman correlation is usually used when you know your data has nonlinear monotonic trend. How do I know this trend exists? Okay, I visualize the data, and from that I see there is no linearity, rather it's a non-linear monotonic trend is there between 2 variables in my graph. Then I don't go for Pearson, I go for Spearman. Similarly for Kendall also. So as I say this, you should notice that means somebody can ask you a question. When should I use Pearson and when should I use Kendall? Then you have to tell, okay, if I see there is a non-linearity in my data between 2 variables, non-linear association between 2 variables by visualization, right? Or somebody has told me, and I know that is monotonically increasing or decreasing, I will not go for Pearson, I'll go for the Kendall or Spearman, right? So this is where one can ask you a question. What else one can ask you a question? One can give you a data and then ask, calculate the Pearson correlation. Actually, if the number of data points, number of samples is 3, 4, something like that, you can easily calculate it by paper and pen, right? You don't need a calculator or something like that. So in an exam, one can always cook up a very simple data, 3, 4 or data point for which you can do the calculation very easily. And then you have to write the answer, right? So in this case, try to understand Pearson, Spearman, and Kendall correlations, and you should be able to calculate them by paper and pen yourself without taking the help of any calculator. And you should understand what is the limitation and application of each of those, right? One important thing, it is not just related to the exam or this course. In the lecture I have highlighted, I will highlight once again. Please remember, this correlation, when you are talking of, you are not actually trying to comment whether there is a linear model, non-linear model or something. You are trying to say only there is an association I have seen. That's all. And the second most important thing that I have highlighted in the lecture also, remember, correlation does not imply causation. That means if I have seen A and B has very high correlation, right? Suppose you are studying something like, you have seen there is a high correlation, Pearson correlation in your data with unemployment rate in a city versus the crime rate in the city. Yes, you have data, collected data. You have seen there is very high positive correlation. That's all. You can only comment on this that I have seen there is a very high positive correlation between unemployment and crime rate in my data. You cannot say, remember, you cannot say my data says that unemployment causes crime. You cannot say that, right? In biology, we face this problem very regularly. Does this gene causes cancer? Does this molecule act as an inhibitor of something? This is causation, right? Spearman, Kendall does not talk of causation. It only talk of correlation. This is a very important point. You have to remember, not just for exam. Okay. Let me move into it. Then what we have learned? We have learned simple linear regression by least square method. SSR or RSS we have learned. People get confused. There are three things. SSR or RSS are the same thing. Then you have TSS, RSS, ESS. If a data is given to you, you should be able to calculate this thing, TSS, RSS, ESS by yourself using paper and pen. Please practice it. Because if you can calculate these, you can calculate slope and intercept. There is a simple formula for that. If you remember, in a simple least square, the slope of the line that I am fitting will be equal to covariance between the two variables and the variance of the predictor x, because I am fitting mx plus c, and this m I want to calculate. Similarly, C has a very simple formula. It will be y bar minus mx bar, where the bar means mean. So you should be able to do it. And it's very easy. If the data set is not very large, if the data set given to you is very small, 4 data point, 3 data point, you should be able to do this. And then you should know how to calculate RSS, TSS, what is the meaning of that. Then you should be able to calculate the R squared, right? And then comes the matrix formulation. You pay attention. In one case, I have discussed that I can do the linear least square fit the linear model using the matrix formulation, where I write the data in this format, y, x, b, and I want to calculate this b, right? So how to create this x matrix? How do I create this x matrix from data? How do I create this y vector from my data? All these has been discussed in the lectures. You create your own data. Just create a random data set, 3-4 data point, and try to write down this in this matrix format, right? Then another important thing in this week, there are lots of actually. So t-test. You should know why t-test is done. Very important question in this case. If you are doing t-test for parameter, what are my parameter? Parameter is M and C. You are calculating them by regression. So when you do t-test for this parameter, what is the null hypothesis? This is a very common question in exams and interviews. If I do t-test for this C, suppose I have estimated this C from linear regression and I want to test its statistical significance. I have done t-test. What is the null hypothesis? Check our lecture. These are very common things, right? We have to understand that what is the null hypothesis for this. Then only I can understand why I'm doing a t-test, fine? So these things you have to be very careful of, fine? And then obviously I have shown how to use the LM function of R to do linear regression. LM function is very powerful. We are using it for many other types of regression also, right? Apart from just simple y equal to mx plus c regression. Fine. For example, multiple linear regression or multilinear regression also you use LM function. Polynomial regression also you can use LM function. We have shown that in subsequent lecture. Possibly you have seen it, right? If you have not seen it, please go and check. Fine. And then in multiple linear regression, again the important thing, how can I formulate my matrix formulation? In that case also you will have this one, y vector equal to x into b. So I have to fit a data to y equal to A1x1 plus A2x2 plus B, suppose. And a data table is given. Then what should be the Y vector? What should be the X matrix? What should be B? Right? For example, this B vector in this case will be, this B vector in this case will be A1, A2, B. You should be able to write this thing so that in any question asked on this, you can answer, right? So the matrix formulation you have to do, okay? Then just like your simple linear regression, you have R square here also. But we have shown that R square get inflated. There is an issue. So you have to adjust the R square, right? So what is adjusted R square? Very common question in exams and interviews. You should be able to calculate adjusted R square, and you should also understand the meaning of it. And you should make a habit of it to use it whenever you are doing multiple linear regression. Do not by mistake use the normal R square, right? So this is one important thing. Then again, you are doing t-test and f-test. T-test you are doing to check the significance of importance, significance or not importance, significance, statistical significance of each of the parameter. You are using f-test to compare different models also, right? So how to do that? And what are the null hypotheses? How to do that? Okay, we use R. In the R demonstration, we have shown how to get those tests also. So you should be well acquainted with it. Fine. And then comes the most important question. If you go to an interview, if you say, I know multiple linear regression, this is the commonest question people ask, apart from this adjusted R square, is that what is the problem of multicollinearity? Not just for exam or interview. If you are designing an experiment, suppose you are designing an epidemiological study or a drug trial study, or you will be doing drug assay on lots of animals, you will decide certain parameters that you will measure in those parameters, right? Weight, feeding habit, blood pressure, height, the thickness, suppose it causes, reduces body temperature, so body temperature, all these things you will measure, right? And then you will create a multilinear regression model. That is your plan. Now, in this case, you have to remember that I should not pick up a variable which one is linearly dependent on another variable. I know that. Then if you do that, I will face multicollinearity problem. So multicollinearity problem is very frequent when you do this type of large scale studies. So you should understand what is multicollinearity problem and how to detect it. One way of detecting is the variance inflation factor, VIF. Very easy to calculate. And you should be able to calculate it from a given data. Right? As I said, apart from adjusted R square, this multicollinearity and VIF is the most common question we ask in interviews and exams, right? So be very well acquainted with it. You should understand it. Apart from its utility, day-to-day utility in data analysis in your lab or for a company, you need to understand them very clearly. Fine? So these are the key points. I just rushed through because in 1 hour I have to complete all of them. What I will suggest you, these are the key points I have raised. If you have not noted down, you can later on also see this video and you revise this week with these points in keeping in mind. And you can always go back to our PMR FTS problem solving session in this particular 4th week and see all those extra problems related to these topics that I have just now said now and practice it. Fine. So that's all for week 4. Before I move into week 5 it is, not week 4, I'm sorry. Week 6, if there is any question, you can post it here in the chat box. Okay, it seems there is no more questions. So let me again now here for week 6, I will highlight the key point that you should remember, right? Please note down, that will help you to prepare also. Although week 6 is over, right? You should be, but when you will revise, keep this thing in mind. In week 6, the first thing we do is a non-linear regression. right? As simple as that. So, and the most important thing to you, apart from exam, just to, if you are trying to master this subject and you have plan in future to go into deeper into these topics of data analysis and model building, linear and non-linear, then you need to appreciate one important thing, that we are still using the linear regression approach, simple linear regression approach, where what we do, we write y vector is X matrix into B, where P vector has all my unknown. And we do some linear transformation and get the B. We will use the same approach. Even when I want to do polynomial regression, means I want to fit my data not to something linear, something completely non-linear, like y equal to a1x square plus a2x plus b. This is a non-linear equation. So we convert this non-linear equation in a way to linear regression problem. That is the trick. You should understand that, right? What we are doing, right? So, and then once you understand this thing, then you should be able to construct again, just like the previous case, like simple linear regression or multiple linear regression. How should I construct y vector and X matrix from data? You should frequently expect that in exam you may have to do it, or if you are doing it yourself, you may have to face it. And then just like any other regression, t-test and ANOVA comes. ANOVA in this case actually can be used to compare two models. For example, model 1 is like this, and the model 2 could be something where I increase my term to power 3. So now, which model is better, M1 or M2? Which one fits better to my data, right? Just the fitting will not help tell me. We have to do statistical test also, right? So then I can use ANOVA. So we have discussed that in lecture. I have shown that in R script also, using R also, how to use it. Please pay attention to that and learn it. Then there are some questions, there are some problems which cannot be solved by this trick of linear regression. I mean, there are some non-linear cases where you cannot do that, right? So in that case, what you have to do, you have to linearize non-linear equation. So you should know what is meant by linearization, right? You should expect a function is given to you and you have to linearize, right? So you should be able to linearize a non-linear equation. But remember, all non-linear thing cannot be linearized. So all those things which cannot be linearized, for that we have non-linear least square also. That also I have discussed, right? We have not gone in details of that, but we have at least shown how to do this, right? So you should learn those things. And obviously, please go through the examples in R where we are doing this type of regression and get habituated. You should be able to do those yourself, right? I mean, I'm not saying that you will become master of something. It's not so difficult. You know, there's nothing to a master of this thing. If you just practice it few and take them, use, there are ready-made data available in your R where you can see, you can simply check, write like this data, this function, right? Then you can see all list of inbuilt data in R. Use any of those data and try to fit linear, non-linear equation to your that data, right? Okay. So in week six, what we are doing, half of the discussion is actually on the regression. We are completing the regression part. And then we are moving into a very important topic of machine learning, clustering and classification. One is supervised, one is non-supervised. I mean, in case of supervised one, you need labeled data. I mean, you have a data set where you already know that what is labeling. I mean, for example, if you have tumor samples, you know which one is benign, which one is cancerous. And then based on that, you actually create a classifier so that when a new tumor sample comes, you can use that classifier to comment whether the new sample is benign or cancerous. Right? So this is using labeled data. So it is supervised learning, right? So there are supervised learning, unsupervised learning. What is the difference between them? Is clustering supervised or not supervised? These type of question you should be able to answer, fine? Okay, we have a question here. After long, let me see what it is. After that, I will complete this logistic regression part. Okay, so if I try to understand that what you are saying is that suppose we are performing linear regression to predict gene expression level based on various features. During analysis, we notice a strong correlation between one feature and the gene expression. The regression line fits the data well. However, when remove outliers from the data set, the correlation weakens and the regression line changes significantly. Why? Yes, good question. Let me. See, yeah. I am not sure here in this case. Okay, you are saying various features. So if I consider that it is multiple linear co-regression, can you confirm whether you are using multilinear co-regression or it is just a simple linear regression? You have just one predictor or you have multiple predictor? Can you confirm? Okay, one predictor. So not various features, one feature, right? So what you are saying, suppose you are essentially, you are trying to write y equal to x plus b, where y is the gene expression, right? And x is some parameter, suppose, some parameter. Maybe that can also be a gene expression or something like that. Now, what you see that when you remove some outliers, the correlation regression line changes, correlation weakens, and all this issue. Actually, the trouble is somewhere else. Trouble is how do you define outlier? So the next question I will ask you, this is very important, not just for your case. So if other people are listening, people try to understand what the question is. Question is, when I remove some outlier, my correlation get disturbed, my regression line get disturbed, it changes drastically, significantly, right? So what is going on here? So actually the trouble possibly, and most of the time it is in what is outlier. So in this case, can I ask you, how do you define outlier? Do you have a definition or you just visually look that some data points are outside, whereas majority else are somewhere else? So that's why you remove that. Which one you do? Yes. So what he is saying is that he done visual. So actually, this is where the trouble comes, and I believe me, I face this question repeatedly many a time in some other context. I'll give an example, and possibly you'll be able to. This is a very common question I face. Sometimes student, even seasoned researcher also ask. I have done quantitative PCR. I have replicates and all these things. I have seen data like this that in one replicate I have got 2.1-fold increase. Another one case is 2.3. One case 1.5. Another case is actually 1. So I removed this one. It's an outlier, right? This is not a scientific method. Forget about a right mathematical method. You cannot. You cannot simply remove this one, or any case, in this case, as you should, you are visually removing it. For example, suppose I have this data X and Y. I see most data are something like this. Then I have here someone here and something like this. So you say visually, this one is my outlier. I will remove it. Obviously, if you keep it, your correlation will be different, your regression line will be different. Now, what is the basis of this as a marking as outlier? Because you are removing it, because you believe that you have a relation here, real relation is here in this box region, and that fellow is outside. So you are actually imposing your belief on your data analysis. That should not be. That means I have a hypothesis. I want to push the data analysis towards that to match that hypothesis. That is not the purpose. You cannot do that, right? Similarly, here removing one is not the right thing. I have got 2.1, 2.3, 1.8. Who has said it is 1 is the outlier? You are saying 1 is outlier. That fellow is saying 1 is outlier because he or she has a belief that gene expression should increase. Now, again, if it is not clear, I'll tell you, see what is happening. Suppose I have a random normal distribution like this, right? 0 mean, suppose. And I'm blindly sample. Okay. I can have a chance to get a data point here. I can also get a data point here. Right? So this one is far one, but this one belongs to same distribution, same population, right? So there are standard mathematical way to define who is outlier actually, right? I have not discussed those, but in a standard statistics book, biostatistics book, there are different methods. Actually, some are simple, some are complicated to define what is outlier in my data based upon those are consistent, mathematically consistent method, right? And from that, using that, you can define who is outlier. Otherwise, arbitrarily do not remove any data from your data set. That is actually not just a mistake, that is equivalent to fraud, right? Never ever remove a data point from your data set. If you believe in that particular sample, experiment has got completely wrong, you know, when you are doing the experiment, you have seen the pipette has fallen out of your hand, so things has not mixed properly, then, okay, you know, that is not a correct experiment. Then only you can remove it. That is not an outlier. That is a bad experiment, right? Otherwise, do not remove something saying that this is outlier. No, you cannot do that. Fine. So that's fine. Hopefully it is clear to everybody. Fine. Okay. So clinical sciences. Method of classification, right? This is called logistic regression. Though it is a regression, but used for, what we call classification. So the key ideas that you should focus on is that what is logistic regression? The sigmoid function, not really difficult mathematically, right? It's very easy. So you should be able to write the correct sigmoid function. And then what is odds or odds ratio, as we call it, right? This is a standard term in classification. So odds ratio, and how to connect this odds ratio and the probability to this sigmoid function. In general, you can go into maximum likelihood problem, but if you find it difficult to understand, you can skip it for the time being. But one important question you should pay attention to that is that when I build upon in the lecture, I only have 2 cases. Either you have disease, you do not have disease, right? It's a binary case, right? But if you have multiple classes, right? 0, 1, 2, 3 classes you want to divide your samples, right? So then you can have multi-class classification, and I have discussed how to do that using logistic regression. And then please do not miss the video lecture on using R to perform logistic regression. And please learn it how to use it, right? What function you are using, how we are creating the confusion matrix, and then from that confusion matrix, how we are calculating the specificity and sensitivity. These are bread and butter of any data analyst who works on clinical data. Specificity, sensitivity, new assay developed, new ELISA technique has been developed in a lab or in a company. What is the sensitivity and specificity of that, right? I can use logistic regression from their data and then create the confusion matrix and then calculate specificity, sensitivity. If I have given you the matrix, you should be able to calculate it by paper and pen. You should not need R to do that, right? So you should understand very clearly what is specificity, sensitivity. Believe me, most people confuse which one is specificity, which one is sensitivity. And they have different names also. I have told that in my lecture as well as in the R, right? So look into those names. People can make you confused by giving a different name, right? Because that fellow may not know the right, may know only the other name, not the in this way as a specificity, right? So you should know different alternative name of these things, right? So you should be able to understand and calculate them from a data. Fine. Then the last thing that we discuss in this week is the different types of distance measure which are used for clustering in the next week, in the week 7. That is the week running right now, right? So in this case, There are many Euclidean distance, Manhattan distance, chord distance, right? So you should be able to, these are something which can be done. Suppose I have three samples, right? Three data points. It is very easy to calculate paper and pen, right? So you should prepare yourself so that you can calculate, right? Yourself. Okay, this is done for week 6. We do not have much time now. I have to rush through for week 7, which is going on now. So in this week 7, what we are discussing, we are first discussing about the clustering, right? So in the last lecture of the week 6, we have discussed different distance measure. Now those will be used in this clustering. And we discussed two major clustering schemes. One is called k-means clustering, which is flat, does not give me the structure. Whereas then there is something called hierarchical clustering also, right? So these clustering methods we will be discussing, right? So in this case, what you have to understand, what is supervised, unsupervised clustering, what is k-means clustering, and the steps in that. And one important question people get confused, what is within cluster sum of square? And what is between cluster sum of square? People get confused with that. Both of these we are calculating in using R. And then there is something called elbow plot to decide the optimum number of clusters, right? Or K, number of K, value of K. So you use the elbow plot. And I think there is an assignment problem on this also. You should be able to identify that, right? So that means where you should have the cutoff. What is the optimum number of clusters? Then what we do, we go into hierarchical clustering, check the steps, and you should be very careful. What type of distance measure you use that actually affect the dendrogram. And you are doing hierarchical clustering because you need the dendrogram. You want the relationship between each of these different clusters. So if that dendrogram changes, then you are in trouble actually, right? So you have to sensibly choose a distance measure, which distance measure you should use. And I have discussed those in lecture, right? That what trouble usually happen and why usually people use complete linkage or average linkage, not single linkage, right? So then I have shown hierarchical clustering in R also. You should be able to do it. Then we come to again to classifier. From clustering, we switch to again classifier. One classifier I have discussed in week 6 with the regression because it is actually regression. That is using that sigmoid function, right? Logistic regression. Now in this week, we discussed two things, decision tree classifier and support vector machines. These are also becoming very popular in case of higher dimensional data analysis, like you have RNA-seq data, microarray data, right? The whole genome sequencing data are coming, or proteomic data are coming. In that case, these are becoming very popular. Decision tree classifier is also very common in clinical field, along with your what we call logistic regression, right? So decision tree classifier, you are creating a tree, binary tree, step by step. And I have tried to explain in my lecture how you build that tree. So in that case, there are certain things comes like Gini index, entropy, information gain. Please check their definition. Learn how they behave. And you should be, you must be able to calculate those by yourself, right? So check those things we have to be very careful, right? And then you should know what is the limitation, that it can actually have overfitting. And then try to understand what do we mean by bias and variance in this case. We say it has low bias, high variance because it has overfitting. If you are working in field of machine learning in future, you will repeatedly face this question of bias and variance. In interviews also, it is very common question to ask the prospective employee that what is the bias, what is variance? Just like specificity, sensitivity is a very common question, bias and variances are also very common question, right? So you should be very clear about it. And that brings us to random forest. And in random forest, we do bagging. You should know what is bagging. What do I mean by bagging and what do I mean by bootstrapping? That you have to understand. I have discussed all this in the lecture. I will not repeat them here. Please go through. But what I'm trying to say, these are key points. Please note them down. And when you are studying through this lecture, pause those places, repeat, listen repeatedly, and try to understand. And majority vote is not so difficult to understand. You can easily understand that is why we use that. The, the last topic for week 7 is support vector machines. And you should follow the order that I have discussed in this lecture. First thing should come maximum margin classifier. Remember, this is not maximum margin classifier is not a support vector machine, right? It's a predecessor, right? From that, you should go maximum margin classifier does not have a soft margin, very hard margin, rigid, either this or that. Then you go to soft margin one, right? Soft margin. So what do we call it? We call it support vector classifier. Right? And from there, both the first two are linear. You are getting a plane. Either your data point is above the plane or below the plane. The plane cannot be non-linear. It cannot take a different shape. That we use, using certain non-linear kernel, we use in support vector machine. So this is step by step we are building. And I find many times students get confused. They think maximum margin classifier is support vector machine. No. Maximum margin classifier is a predecessor. From there we are starting. We are getting the idea of margin, right? And from there we are moving to soft margin in support vector classifier. But still we are facing that, okay, there is a trouble that there are some problems are non-linear. We cannot use a plane to separate data into two groups, right? So then we are going for support vector machine where this shape of this dividing plane can be something non-linear also, right? Even a sphere can be like that, where some data point of one class is inside the sphere, something is outside the sphere. That is not possible in standard support vector classifier. That is possible when you use support vector machines. So these are the differences, right? So that's bring me to the end of the discussion on key issues up to week 7. Week weightage lecture is not public yet. So there is no meaning in discussing that. So I hope you will be able to go through those. And if you have any question, we have few minutes left, you can ask. I will try to answer this question. Okay, just to remind everybody once again, that remember every Saturday 6 o'clock there is a online live problem solving session where our PMRF TA go through the important aspect of that week's lecture as well as solve live in front of you some extra problems. Please attend those. This week there will be one, then next week will be another one, and for the benefit of all those students who will be appearing for the final examination, there will be possibly another additional one. That information will circulate. We will decide when it will be, but please attend them. Go through the additional problem that we are discussing. These are always uploaded in YouTube, so you can always access through YouTube. But when you attend them, you can actually ask questions and doubt, and he will be always very happy to clear your doubts. So please attend them, right? Just studying alone through an online course never helps. You must have lots of questions coming to your mind. Don't keep them unanswered. The other one that reminds me that I see some of you are very active on forum where you ask questions. That's a good thing. I will request everybody else. I will say that please, whatever questions coming to your mind, whatever you are failing to understand, please post the question on the forum. Usually twice in a day, we check the forum and try to answer all questions. Right. But what I will suggest you, please write the question in such a way that one can understand exactly what you are asking, right? So you construct in a correct way and ask a specific question. If you have multiple questions in mind, please don't tag all of those and write all of them in those in one post. You break them in multiple posts. I assure we always answer them as soon as possible. And that is the best way. If you find, if some of you are shy, that you don't want to, ask this question in front of everybody, okay, there must be some people like that. Don't worry. My email ID is in public domain. You must be aware of it. It's very easy to find my official email ID. Drop me an email. Trust me, I will answer. The only requirement for me is that please write the question clearly in a legible way so that I can understand, grammatically correct, something like that. You formulate the question properly so that I can understand what you are asking. I assure you, every time that question comes, I answer it, right? So you have to ask questions. You cannot study alone, right? So take help of this. Me, my TAs are always there to help you. Is there anything else? Anything regarding the exam or assignments that are bothering you? I have not got any information of exam got postponed. If exam get, remember one thing, this exam, the final exam is conducted online through by NPTEL centrally, right? I or here in my campus, we do not decide any date or anything. Like this whole thing is decided by NPTEL. I am not aware that there is postponed or anything. If you have registered for the exam, you must have got a mail giving the date, right? So you should follow that. Regarding any exam related question, you should always post question to NPTEL directly, right? Contact them as soon as possible. And you should always follow the mail or phone call, whatever message that you are getting from them only. Do not trust anybody else's words, not even mine, because we are not conducting the exam. They are the exam conducting body, right? You may consider it as if we are the teacher teaching you, preparing for you a competitive exam, and somebody else is organizing the competitive exam, right? So it is better to ask from them always. You listen from the horse's mouth, the way we say, right? So in this case, you should always contact for any exam related question. Somebody may have issue it with the exam center, may issue with admit card. I know people face this regularly, right? So if you face all these things, any question, you should always ask the NPTEL. Yes, if you need to know that what type of question I can expect, how to prepare for the exam, all these things I will answer. Fine. Okay, I believe there is no more question then. Then almost we are done. Few minutes left, so we can actually close this live session. As this is my last live session this time in this January session of 2024, I thank you all for registering for this course. I'm particularly very excited to see that this time the number of students who has registered for the final exam has increased largely. So I'm very happy as a teacher that, okay, that means students are actually getting excited about this course as well as they are finding this course very useful. I hope all of you, whether you are giving the final exam or not, will find this course useful somewhere in your career, somewhere in your academic career or other career and subsequently. I thank all of you for joining that course and particularly thank today all those who have joined today for this live session. I wish you best of luck for all your academic and future endeavors, right? And particularly those who will be appearing for the final exam in the certification examination, best of luck. And remember, we are always one email away from it. Don't consider yourself alone. If you have any question anytime, post it. Thank you for joining. I will end the session here.